Hello again. Welcome back to SwiftUI and creating the calculator. So far, we've got our calculator rendering. We see the UI element is displaying, and we've created a global state object that handles properties and has a method that we can use to handle clicks on buttons or taps on buttons, right? So we've got this connected to our view. So changing, the property for display will update the view over here. And we can see that if I click the play button here, as I tap here, it's adding numbers. Now, there's a couple ways to handle the values in the calculator, right? So method number one is with a string. So if we think about tapping the buttons on the calculator, you might start with a string and it's got a 0. And if the value is a 0 and you tapped a number, you might say, let's replace that number with, I'll use that to say replace with the number. And let's say the number was an 8, right? So now we have display of 8, but it's a string, right? And if you, let's say, then tapped on the number like 7, right? Then, you might have a 7 and an 8. And what you do is we'd combine them together. We'd concatenate them, the two strings, to come out with a new string, and we'd have 87. Okay? And then if you tapped on, let's say, the 0, you'd get a 0 here, and we'd concatenate, and then we'd have 870. So using this method, we'll put the string together, right, the number that we want to do the math with, as a string, and we'll assemble it kind of like you think about it like as writing the number out by hand, okay? And this is going to have some some pros and cons for it. I'll just admit I might regret choosing this action later and want to change it, but this is what I'm going to go for now. But let's talk also about what the other option is, right? Or actually, even before we do that, let's talk about some of the pitfalls here, right? What happens when you enter a like the negative sign, like you tap the plus minus button, right? Like what happens here? Well, in that case, what we need to do is either one of two things. We can convert this to a number and then multiply by -1, or we can add the minus symbol as the first value, right? So, or the first, we can concatenate the it's kind of like we would say plus 870. So we'd put it together in this order, right? The other thing we can do is oh yeah, and the other situation that's going to happen here is if we have a negative number and you hit the button here, then we have to kind of look for a character here and see if the minus symbol is on the front and then scratch it off or remove it, right? So that's one way to work. So like this is kind of nice because building the number is easy, right? So these steps are easy, but then when it gets into this step here with the minus sign, it's a little ugly, right? Also, if we add a decimal place, so for example, if I had negative 870 and then I typed the dot, well, just adding the dot is okay, right? There's nothing wrong with that. But then, if I have negative 870 and the dot here, and then what happens if I hit the dot again, right? Like that's kind of a problem. So in this case, we have to check for the dot, right? And if the dot exists within this string, we can't add another one, right? So this kind of has some things to recommend it, and then it has some drawbacks too. There's some like weird exceptions, right? I'm going to use this example to do the code down here. Again, like I said, maybe I'll regret it in the future. Let's talk about the alternative, right? So what would our alternative be? Right, so the alternative would be that we keep track of the value displayed by the calculator as a number the whole time, and then we always just convert that number to a string to display it, right? Here, just whenever we do the math, like if you hit the plus sign, we'll actually have to take the number here that's a string and then convert that to a double, do the math, right? So, we keep track of a string here until we actually have to perform a math operation, in which case we're gonna convert it to a number at that point, right? The other method to use is to actually just hold the number numerically in the background. So if you imagine, like, if we had the number 8 here, or actually let's say we have the number 0, right? And then you hit the number 8 on the keyboard, right? So you did the number 8, right? I don't want to put the plus there. What if I put, how about the arrow like this? So you hit the number 8, right? So what we would do is we take the 0, multiply by 10, and then add 8, right? So this would be, 8, or it would be 8, right? Because 10 times 0 would be 0, plus 8 would give us 8. So now I've got 8 here, and then let's say I hit 7, right? So so that means, if I hit the 7 on the keyboard, we'd take 8, multiply by 10, and then add 7. Okay, so this method is nice because we actually have the value as a number the whole time. So anytime we want to do math on it, there's no conversion, right? Where this gets ugly is when you add the decimal, right? So as soon as I add the decimal, then I start having to keep track of the digits after the decimal, right? And I have to count how many digits are after the decimal in order to calculate what I'm going to add, right? Because I need to divide the new number by the number of tens places after the decimal, right? So this one gets kind of ugly in that zone. So it's kind of easier in some zones and then kind of harder in others. I'm going to take this approach though here, where I keep track of the number as a string. Okay, so and you can take a different approach too. And you'll see as we put this together, that it'll be kind of obvious, like where to put your code, right? So let's dig into this, right? So so far we've got our key pressed, and right now we're just kind of naively, we're just adding the character to the end of the string. What if we want to check the character first, right? Because if I look at my calculator here and I click the 8, well, that's pretty good, except it kept the 0, right? So that means that if I'm starting with a 0, I need to just replace it with the new character, right? So there's that. And then if you tap on one of the other buttons, like that's kind of weird, right? Like I can't add AC on there, like that doesn't work, right? We have to do something different when you tap this button or one of the other buttons, right? Okay. So let's give it a try, right? So what I'm going to do is I'm going to go into my global state here, and what we'll do is we'll check the key that you pressed. So I'm going to do that with a switch case, right? And we're passing the key in here, and it's a calculator key type, and the switch case is great for checking enums. So I'm going to put key here, and then I'm going to try and match the key against the various, potential keys that you can press. I'm going to just put a break here on the default, and under the case, let's imagine that the case is a 0, or the case is a 1, or the case is 2, or 3, or 4, 5, 6, 7, 8, or 9. Right, so if the case is any one of these, what we're going to do is we're going to look at the number. So we'll say, hey, if display is equal to 0, then we're going to set display equal to the number that you pressed, right? And we can get the number from the key and get its raw value, right? Because remember, our enum is just a list of strings, right? They've been kind of associated with one of these symbols though, right? So if I look at the calculator key here, you can see every one of the numbers is just a string, right? So we can just concatenate that. So we'll just add the raw value. If it's not a a 0, like we have some other character in the display, what we can do is we can just say display dot or display equals display plus the character, right? So that covers one of the situations here. Oh, I can't use a 0 here for display, right? So what I need to do is say, let's do calculator key dot 0 dot raw value, right? Yeah, there we go. So I got rid of all those error messages, right? So let's give it a try now. So I've got my calculator here, and it's starting up. Oh, great. So it shows a 0. And if I type in an 8, let's say, it replaces the 0 with an 8. And then if I type in a 7, it concatenates or it appends the 7 on the end. And then I can type a 0. And then if I hit a dot, oh wait, the dot isn't handled, so we'll need to do that, right? And the same with these, but actually that's good. At least it's not appending these other characters on there too. Okay, great. So that's a good start there. Let's try something else now, right? So I'm going to go to the calculator state and let's try and handle one of the other cases. So let's say case of the dot. Oops, I typed the curly brackets there. So for the dot here, what we want to do is we want to ask, does the string already contain a dot? If it does, we can't add another decimal, right? But if it doesn't contain a dot, then we can just tack the decimal on, right? And in the end, we're just going to convert the value to a double in the end anyway, right? So let's try that. Let's say, hey, if display contains, right? And then I'm going to look for a particular character. So I'll choose contains element character. And then the character I'm looking for is the calculator key dot raw value. Okay. So that means, like, by doing it this way, we can always, change the dot that we're using in the calculator key enum, and then anywhere else that uses that dot will always match up, right? So this is kind of nice for us, right? So so if it's the dot, if it contains the dot, then we'll just break, because we don't want to do anything, can't add another dot there. And then if it doesn't contain the dot, then we can say, this is display plus, and then we'll add the dot on the end, right? So we could just add the key here because it's the dot, but maybe I'm just going to spell it out just to make it clear, right? So we'll say dot raw value. Okay, and again, we're starting to duplicate code like this arrangement here where I'm display plus the raw value and display plus the raw value. Maybe, like taking display equals display plus another key. We might move that into its own function too. But I think for right now, this is fine, right? So let's give that a try. Let's go back to our calculator here. Great, it's showing a 0. Let's make a new number. Let's do 3.1. Oh, wait, my dot isn't working there. Could be that it's not updating. I was kind of having trouble with that before. So let me try that again. I'm going to restart it here and type 3.14. Let me do this. I had a couple. I'm not quite sure how to get this. I think there's a menu option in here that has it read. I'm still new to SwiftUI, but in the old Xcode you could rebuild a project if you were running it in a simulator. I don't know if there's one of those. There probably is. There's probably one of those for SwiftUI. You know what? After this video, I'm going to look that up. I'm actually going to just reopen this again, right? Because that usually does it for me, but it's getting kind of annoying that happens a lot. Let me run it again. Okay, so there it started. I'm going to click the button here and try it again. So let's do 3. Oh, there it is, right? 1, 4, 5, 6. Okay, let's see if we can add another dot. Oh, great. So I'm tapping and I can't add another dot. Excellent, right? Okay, so that's looking pretty good. Let's handle one more situation. Let's handle this plus minus button right here. So this should, convert this number to a positive or a negative number, right? And there's a couple ways we can handle that, right? Like we could handle it as, like I said, we could convert it to a number and then multiply by -1 and then convert it back to a string. I'm going to add a new case here for the plus minus button. There's probably like a more, mathematically correct name for that operator there. I'm not sure what it is, but plus minus, I know what it is, right? Okay, so we've got this. So there's a couple ways we do it. We could, convert to a number and then multiply by -1. Oops, -1, right? The other thing we can do is we can look at the string. So check the first character. Is it the minus sign, right? Right, and if it is, then remove it. And if it's not, we could add it, okay? So I don't know which one would be better, but I think since I'm treating this as a string, maybe I'll just continue treating it as a string, okay? So I'm going to go with the second method here, okay? I noticed that Swift, I had to look this up, right? But Swift doesn't have like I'm used to, I do a lot of JavaScript. So JavaScript has like the array operator, the subscript, you can use that to access a character in a string. And Swift doesn't seem to have that, right? But you know what I found was I found this excellent, this Hacking with Swift has a lot of awesome Swift stuff. This guy, actually, I've been following this guy's site for some years now. He's been doing this since, since Swift came out, actually. And, so he's got a lot of great information. And he's got this little extension here written in. And so I'm going to just borrow this extension, right? So using the extension here, you can use the subscript, right? So you add this in. An extension is basically like adding a new method or something to one of the built-in classes or structs, right? So string is a built-in struct, and the subscript is going to add a new feature to it, right? So I'm going to borrow this and go back to my code here, and I'm going to make a new file. So I'll do Command N. I'll choose iOS as the file type, and choose Swift as the file type, and then I'll click Next. And I usually make a file called extensions and put the extensions in there. Or if there's a, if they extend a specific file, I might include it there. But this is kind of general, so I think I'll just make the extensions Swift file, and I'll add my extension here. And then maybe just for clarity, I will also credit Hacking with Swift there. So this is great. So once we have this in here, let's say adds subscript to string. I don't know. You can put some notes in there, right? Okay. So now we've got our extension there. So let's check here. So what if we say, hey, if display bracket character 0 equals calculator key dot minus dot raw value, right? So let's see if it matches the raw value. If the first character is a raw value, here we want to remove, right? Remove the first character. Else we want to add it, right? Add, right? Actually, it's like we want to put it at the front, right? So we'll append at the beginning, right? So let's do that. So let's do the add first. This is the easy one, right? So what we'll do is we'll say display equals, and then I'll just get it again from our enum, right? Minus dot raw value plus display. And now we'll remove it, right? So we'll say display dot remove at. So there's a couple of methods here. So I'm going to say remove at, And then what I'm going to do is I'm going to get the first index. And this is a little weird in Swift. Swift strings, the characters are in sort of an array internally, but since characters can be multi-byte, if I understand correctly, they may not, the index is not really what you think it is. Like in JavaScript, everything's just at an index. In Swift, it's a little bit different, right? So I'm going to get the start index, this guy. So I'm going to say, hey, let's remove the character that's at the start index for our string, okay? So I think that looks pretty good. Let's give it a try, and hopefully we've got this part working right here. So let's go back to our display here, our view, and resume the view. And let's give it a try. So let's say, let's do 3.14, and then I'll click the button. Oh, there's the minus sign, so that worked. And if I click it again, oh, nice, right? Okay, great. So that's working pretty good. Maybe we can tackle one more thing in this video. So actually the clear button on the calculator is more complex than you think, right? Because if you, let's try and tackle it right now in a simple way, and then we'll have to come back and do a little more work on it. But you'll notice it says AC, and that means like everything is cleared, like there's nothing going on in the calculator, right? If you, as soon as I start typing a number, like if I type 1, you can see the switches to clear. And if I click it, it goes back to AC, right? So what happens if I type in a number like 1.168, and then I do plus, and then I type in 7, and then I hit clear, you'll notice it goes to AC and it says 0, but really the 1.168 is still on in the memory of the computer. So if I say, and the plus sign I think is in there too, right? So if I hit a 9 now and then I set equals, you see it gives me the answer, right? So if I did the same thing where I click this a couple times to go through the AC, like if I get to the AC and I click it, it actually clears everything, right? So now there's nothing in the memory, and if I hit 2.3 and then I do plus 88, then I get 90, and if I clear, it clears just the last entry, and then if I clear again, it clears the 90.3 or whatever was left over, right? So the clear button's a little more complicated than just clearing the screen, but for us, since we're treating the value here as a string, and if we want to just treat the clear button in a simple way, we can just set the string here back to 0, okay? But later we'll want to treat it maybe in a more complex way. So let's give that a try right now, and that'll get that part kind of started, right? So in our case right here, or in our switch case, we've got a case for the numbers. So this is how we're going to handle a number. We got a case for the dot. Here's how we're going to handle a dot. Here's the case for handling the plus minus button. Let's add another case for the AC. Actually, what did I call that in here? Let's take a look. So I've got the clear and I've got the all clear. So I'm set up to use the clear, but right now we're just using the all clear, right? So because that's what we have here, right? So let's check for that. So let's do all clear. Actually, we can check for both, right? So we'll check for either of those. And when we get one of these, we can just say display equals, and we'll get let's get our calculator key .0 value. So we'll just grab the 0 from the calculator key, okay? And let's give that a try. I think that should be working, right? So let's try it out. So I'll do 88.7, negative 88.7, and then I'll hit the all clear. Oh wait, it's not working. Maybe it is working though, but it just, let me do that again. I'm gonna look that up after the after this video, and in the next video, if I find a good answer, I'll include it in the video. So let's try it one more time here. So let's do 50. Well, wait, I gotta run it. So let's do 55.5 clear. Oh, nice, right? So let's do 55.9 negative clear. Okay, so it's not complete, but it is working. Like we're able to enter numbers, right? So anyway, thanks for watching. I hope that this is informative and helping you move forward with Swift, SwiftUI, and your general, computer science exploration. Okay. See you in the next video.